Yeah, so this is not actually my talk. This is John and myself. John and I co-founded a company called JUXT about 12 years ago, which has recently been acquired by a company called Grid Dynamics as of last week. This is actually John's talk and about John's tech journey and John's experiences. And I'm going to apologize that John can't be here because he's actually at another conference. He said he had to go to a more important conference in New York. So he kind of asked me, would I give his talk for him? I said, sure. What's the title? And he said, Dynamic and Proud. And so, can I change the title? He said, no, it's already been submitted and accepted, so you're just going to have to work with it. And I feel I've been dealt quite a bad hand here, because the truth is, I really like statically typed languages. And in fact, I started with C and C++, but in 1995, Java came out, and I became an avid Java geek, and I went through every version of Java up until, I was on the Java train, going to every single station up until the end of the line, which was Java 8, of course, and then there's been no real changes since. But after that, 15 years in Java, I moved into another language called Clojure. So I've had 15 years with Clojure. So this talk is really my perspective of having kind of half my career in one camp and one in another. John was concerned that the religious war between dynamic and static languages has kind of tailed off, and I think he wants to stoke it up again. And I was thinking about this: who actually won the war, and is it still going? Because I think there's a sense that a new generation of programmers kind of think that the static languages have won. There's certainly a resurgence, and certainly if you talk to somebody in JavaScript who have discovered TypeScript, there is this feeling that that static languages have won. And I really like static languages. The feeling that you get when you immerse yourself in a type system and you run the compiler and you think everything's going to work, and the compiler says, no, look, you did something wrong. And you think, gosh, imagine if that got into production. And you begin a sort of healthy relationship, a dependency relationship on this wonderful compiler. There are some people who say, and it's true, that because you're doing more checks, the compiler's doing checks that you would have to do in runtime, and therefore there is a performance improvement that you get. Also, back in the day of Java programming, when there was about 11 packages, you could kind of learn all of the API calls that you would need on a day-to-day basis. But now there are thousands. So having an IDE pop up, did you mean this? This is your choice. And it gets all of that from the static type system of the language. So that's very useful too. The final thing I think is what we all feel is when you are at one with the compiler and you're building a type system and you're refactoring, and we've been talking about today with Martin Fowler's interview about that feeling you get when you're designing and you're iterating the design, and the design almost gets better and better and better and more perfect, and you spot opportunities to improve the design, and then you end up with a really good design. Rather than having to think about it up front, you let the design evolve. And that feeling of designing through refactoring is something that I think is enabled by a good type system. So I could talk about all the benefits of static typing. Honestly, I could spend a whole talk talking about how good static languages are. I could do. I'm not supposed to. But if you want to go and find more information about static type languages and the benefits, I recommend this talk. This was done at Strange Loop 10 years ago. The type systems, the good, the bad, and the ugly. I've put QR codes on some of these slides if you want to take a picture of them for watching them later on. So Paul and Amanda asked Strange Loop audience. They prepared this talk and they went around on the corridor track and asked them, what do you think of type systems? And apparently many people at Strange Loop said, well, I don't need one. People who go to Strange Loop are a little strange. And they thought that this was because they needed educating. So The feeling was that people who don't like type systems or don't feel, these dynamic programmers who go to strange loop, perhaps they just haven't been educated, or perhaps they've been exposed to type systems in things like Java and C#. They just haven't learned how to do type systems with a great type checker like Scala or Haskell. Maybe there's something wrong with people who don't enjoy static programs, and in fact ask the question in their talk, is it even ethical to use a dynamically typed system today? So hands up if you've used a dynamic type system. Oh, you have. Are you feeling ashamed? Maybe you should breathe out and just spend a moment reflecting on that. Perhaps you should just breathe in. You feeling the shame? Breathe in the shame. Good. Are there any reasons to adopt a dynamically typed language? Well, there are some benefits. These are not, for me, killer benefits. But it's true that if you've ever spent an evening trying to get all your generics warnings to be completely zero and to try and fighting against the type system, you may realize that is time that you could have been spent coding other things. And so, yes, there is a little bit of experience in dynamic programming languages of a freedom. They are supposedly easier to learn because there's just less of the language. You don't have to learn the type system. I don't think that we should optimize laziness in developers. I don't think that's a good reason. The ability to do meta-programming. So in dynamic languages, you can do more at runtime, and that's kind of by design. You're having to do defensive checks at runtime, and you've just got more that you can do because you can do things that the compiler wouldn't allow you to do. You can instantiate your own objects and do things very dynamically. And I think the other thing that people point to, especially in languages like Clojure and Lisp, is this interactive system that you have with the REPL, where you can try things out very, very quickly and evolve that design by asking questions of the system and coding it from within. Is there any more to dynamic languages? I think Nathan is a programmer. Nathan Mars is a programmer famous for work in distributed systems. He went dark for about 10 years and just surfaced last October with a distributed system called Rama. And Nathan uses Clojure, and he thinks, this is a kind of a provocative statement, but I put this up here because I think that there is something much deeper with dynamic languages. If the replies to this tweet are quite interesting because they cover most of the debate, the old debate between static and dynamic. So it's worth exploring. But the responses really echo something that I feel, that refactoring towards a nice design is actually much nicer in static languages. So static or dynamic, it depends. And I think it depends on what is it that you want to fix, that you want the compiler to enforce, and what is it that you want to flex. And I'm going to argue for the rest of this talk that I think there is something in the domain model that we create in our languages that we want to flex. We don't want the compiler to check the domain model. So to explain what I mean by this, I need to define what we mean by a type, because the word type actually means many things at once, and it leads to confusion. When we use the word, it's just heavily overloaded as a word. So I'm going to explain this by reference to different types of type. Now, most languages have primitive types, Boolean and float, integer and character and those things, and we compose those into more compound types. Like a string is really a collection of characters. But I still think that these simple types are worth having as values, as immutable, and I call them atomic. I don't want to break open a date and set the month. I want a date to be a fixed value and be immutable. I don't want to break open a money class. I've seen this happen in a bank where a money object has had its currency set, but not its amount. gives some kind of setter method and all hell breaks loose. I want these things to be values, and I want them to be checked by the compiler. And the same with aggregate types, which here is the arrays, the sets, the lists, the maps that we use in our code. I don't want to have a function that works on an array of strings and is given an array of integers. That's just something I want the compiler to check for me. But there is this idea of a record type. Java 14 introduced Java record types. It's been, in Kotlin has data classes, and even Clojure has records. And these things are composite aggregations of different elements. What I mean by that is that they often are records that reflect a business domain. So for this talk, we could express this talk in JSON. Java here actually allows you to create a record which allows us to compose these things that are belonging together for a particular business process or a business need. I don't think these types are universal, by the way, and I think this is part of the problem. By putting them and codifying them into our programs like this, we're kind of making statements that these things are universal when they're actually very contextual. And the reason why I think you need the domain to flex is that the domain is always evolving. And I think most people are aware that change is something that we cannot stop. You can't just stop the progress. Where does progress come from? Change is really divided up into two ideas, that there's real change, that you want to produce a new feature, or your boss is saying that there's a new product, or you want to go to market with a new financial instrument, you want to trade something new, or might be having new regulations. These are things that the market or the external forces are bringing to bear, and this is why we have to change our programs. And then there is another category of change, which I call epistemological change. So this is where our approximations aren't accurate enough. So a domain or a set of types is only really a best guess as to what the business is. And often we need to evolve that, and we find out that we're wrong. And so as we improve our theories about the way the business works, we can improve our types. And this is what's going on when we're refactoring. We're trying to move towards a better approximation, or because we get a new feature request. But I've noticed, coming back to work on Java projects, having had some sort of time away with Clojure, that I see almost every project that I've witnessed and around the company has this quality that we use good agile practices, but they're constantly into change all the time. And we're trying to optimize that. We're trying to make it quicker and quicker and quicker to change things. And I'm arguing that there are some things that should just be slowed down. We don't want to create systems where there is a dependency that is created on the developer team. I work with some banks, and there's big systems that don't have anybody who can work on them because there are thousands of systems. We need to work out an end game for the programs that we build. And I think too often the agility in Agile is actually a characteristic of the team and not a characteristic of the systems that are produced. Because it depends on if something change is required, you need the developers to come back into the room, stoke up the fires of the build machine, produce a new system, redeploy it. And it's okay if you can do that every 30 seconds or 15 seconds, as businesses do, but it is dependent on having people firing up the build. These systems don't flex with change in ways that they used to do. It didn't always used to be like this. Consider this piece of software here, spreadsheet. If all of the Excel developers stopped working tomorrow and retired, how many Excel users would actually notice? I don't think hardly any of them would notice. I know people who work on Excel versions that are decades old, and they do their own home accounts, and they wouldn't notice that Excel didn't drop new features. I mean, Excel still does drop new features, don't get me wrong. We still have to pay for it, and there's subscription plans. But if it didn't, the world would carry on going round, because in these products, the domain is actually flexed by the user. You can put anything into this. It's an extreme example, but it's what I'm talking about when I say dynamic system. For me, this is a dynamic system. And a dynamic, this is really the goal. This is if we want our systems to flex and to outlive us and to be able to stop working on systems, we need more characteristics like this. So what is the alternative to the way that we code right now? I think one way is that we could ban record types. When I first learned functional programming, I was working with a colleague, Tim Williams, and he used to tell me that functional programming was all about building little compilers and little interpreters. And he was saying, only build those things, and everything else should be input. You just write functions that will just be almost universal, and they will be told what to do by a stream of input, and that input can change. And that really kind of has been a big inspiration on me. So what we're seeing here is, if we get rid of our record types from our static systems, where do they go? I have some candidates for what schema choices you have, and there's a lot of choices. But it does require your systems to be more abstract in a way. Instead of knowing what the types are, they're going to have to read the types up from some sort of input. They're going to have some introspection. They're going to be harder to write, basically, but it may be worth it. One example is JSON schema. Hands up if you've heard of JSON schema. So I think for actually specifying the constraints of what your input arguments want to look like, JSON schema may be too overkill for this. But for many data shapes that we deal with, that we use a type system for, can actually be expressed more flexibly with a set of constraints. And you can code up these constraints in JSON schema. JSON schema supports enumerations, all kinds of dependencies, all kinds of combinations of things. Actually, JSON schema is incredibly powerful. You can be very contextual with these kind of specifications. Instead of types, let me explain what I mean by that. There are some, you may create a medical record, for example, where you want to capture somebody's date of birth, a name, an address. And they arrive at the hospital, and they're unconscious, and you're not going to be able to ask them the date of birth. Sometimes you just don't know, and it'll have to be null. But if later on you're trying to work out if they've been at the hospital before or what their medical history is, you may need the date of birth. So sometimes the nullness of something is contextual, depending on whether you need it. If you're shipping, for example, doing a shipping application and you're shipping goods out of a factory, you may need just the name and the address of the recipient, but you might not need to know how much the price of the goods were to charge. That might be a function of the accounts department. So the nice thing about making types that are, well, not types, sort of specifications, is that they allow you at point to point, in different contexts, to say, this is what I need, and this is just what I need. There is some elements in TypeScript with structural typing that you might have seen where you just say, look, I don't need it to be a type of employee, but I do need something that has these three attributes. So that's flexible too. The other benefit of JSON schemas and things like this is that we can pull them out of our programming languages. We can store them in files. We can share them with colleagues who may not be working in our programming language. So this idea of being able to have a shared language and to start putting records in something that is external and can be versioned and put in version control. Too often, we are creating different representations of our domain in different languages. And then if you find you're serializing, you're outputting and writing to JSON or XML, and then colleagues working in other languages are writing deserializers that are bringing in that data. There's a lot of work that is done just by mapping one type system to another through network boundaries. And we do this kind of unthinkingly. But my argument is that dynamic systems, or at least there is an opportunity here to start encoding what we mean by a domain in these schema languages. My company, JUXT, had a number of experiences with building systems just like this. We've built some financial systems where new products, new financial products, can be onboarded without one line of change of code that needs to be changed, without any releases. And the way that's done is the people who structure the products, the quants and the mathematicians, can create a JSON schema that represent the range, the types, or the type of the financial product. What kind, whether it's a bond, whether it's an equity, whether it has some insurance, whether it has a cash flow leg, or all those kind of attributes that you need to know, the notional, the price, the quantity of a product. And so they can create the type, and then that type flows all the way downstream. User interfaces can be generated from that description. Validators can be, whole trading systems can agree what the terms are by just agreeing and what the JSON schema is. I don't think JSON schema would scale to an organization, but for a particular stream of 5 or 6 applications all talking to each other, it works very well. And what it does is it releases the burden of having to keep the CI/CD pipeline warm all the time and doing release after release and all the testing. It just says, look, this stuff is done. If we need to make a fundamental change to these internal compilers and interpreters, then yeah, sure, we can do another release. But it does take a lot of burden from the organization and allows them a degree of agility that they can put something into production almost straight away, instantaneously. There are other types of schema that I want to, just for completeness, mention. If we talked about the if you're creating types for your whole organization or the planet, you might choose to use RDF and semantic web technology. There's a renaissance in semantic web technologies, partly because of the ability for AI and large language models to learn well-known attributes from the web and learn all that information so that large language models actually know this RDF stuff really, really well. So if you express your system in terms of RDF, you find there's a lot of leverage that you can get from Gen AI. I've had experience using GraphQL schema to create large type systems, which then you can introspect. GraphQL has a quality that you can introspect at runtime. You can ask queries of the types. We've also touched upon, well, XML schema. Nobody talks about XML anymore, but XML schema had this, that there was a nice competitor to XML schema about 20 years ago called relaxing, and that had a nice property that you could write XML specifications just for those minimal cases, like you're in that factory and you want to ship products, and you can create them such that an XML document didn't have to say this is the type, the type that would define all the XML documents. It was just this just-in-time specification for what you needed at the point that you needed it. And of course, all these three have this quality that you can produce them in data and store them in databases. Database schema, there are a lot of systems that you put the database schema in place and it will introspect and generate all your code for you, and you have nice user interfaces. The problem kind of with database schemas is that they don't allow you to have multiple schemas at the same time. It is a kind of all or nothing. You can't really store a database schema in a database, or at least if you do, the database schema is only of one schema at a time, which then, when we're talking about evolving the domain over time, you kind of get cut off from the past. I've got something to say about that in a minute. And schemas are just one aspect of something I call form. So I think this is not just for types, it's also for workflow, business processes, for rules, there's domain language, ontologies. All of these things I put in this layer called form because I think they're an evolving organizational knowledge. In fact, an organization, its business knowledge is really the sum of all of the constraints and forms and things that you fill out and constraints and rules, and you put them all together, and that's what the business is and how it understands its place in the world. And that is the thing that evolves. And so we want to decouple that from our code. So in this talk, we're coming to a close soon. We've touched on really the top level of this diagram here. But at my company, we have a methodology which says really you need to keep all of these four things separate. The forms that we've described in schema, they need to sit somewhere in a database. And when we store facts, we want to store those facts across the whole of time. We don't want to just capture today for reporting and all kinds of reasons and for audit. We need to capture yesterday as well. So how do we solve this problem of evolving schemas across time? At the database level, this question has what inspired us to try and build a bitemporal database. We heard today Martin Fowler talked about schema migrations and being agile in the database. Schema migrations can be very, very important. The engineers behind XTDB have managed to relax the idea that every table needs to have a fixed schema at one point and actually allows it to evolve across the timeline. This is one of the features that is almost necessary if you're building a database that has to allow you to do queries across time. So facts that you store in the database can be retrieved. That when you do update statements in a database, there's no way of getting rid of the old version. It's kind of everything is then remembered in an immutable database. But there's more talks on XTDB and how this works, but it is kind of partly our challenge of how do we cope with change in our requirements and change in our data and change in our organization. This is really the next big challenge. The system is dynamic, and if you want to hear more, we've got a JUXT cast on this topic. This is where you will hear John, because John's on this episode. So look up JUXTcast on Google. We're talking about a few other aspects of this debate about static versus dynamic. So wrapping up, we have a little bit time for Q&A. I would say let's design systems that can flex and adapt to change. Not everything has to be static. The picture of here is of a damper inside a building. The large skyscrapers look like they're entirely rigid affairs, but they're not. Inside them, they've been built to flex with the wind. As the weather changes, you don't know where you need to flex and what you need to keep rigid. Skyscrapers are much more flexible than they look. Let's design systems that survive the development phase. I know it's very profitable for us as developers to never be out of a job because the systems that we create always needs us to be there just in case of that change that we know is going to happen. It's almost like a safe bet. But I think the challenge with now is this vast amount of legacy that we've created. I think we need to start thinking about how we more smoothly work out a kind of the end game for systems, how we sort of keep them alive without the constant attention of teams of developers. It's just, we're in the long tail, and the long tail is getting expensive for our customers. And let's build dynamic systems. Let's aspire to building things that look more like a spreadsheet than the brittle systems that we create today. And I think dynamic languages can help. So thank you very much.